Open up your books to page 752. We are doing Chapter 9, Lesson 8, focusing on the area of trapezoids today. Now, we've learned a lot of different formulas so far for how to find the area of things, beginning with a rectangle, which was simply length times width. So, of all the area formulas that we know so far, length times width is for a rectangle. And then we have used base times height for a parallelogram. And we discovered that we can take two triangles and put them together, create a parallelogram. So the formula for a triangle is 1/2 base times height, or base times height divided by 2, which is dividing by a whole number 2 is the inverse of multiplying by a fractional 1/2. So these are all the things that we've learned so far. So this was for a rectangle. This is for a squishy parallelogram, which rectangles are parallelograms, but they don't all have right angles. And then we have the formula for a triangle. Okay, which brings us to our formula for a trapezoid, which is actually made very similar to the triangle. It's based on the fact that you can make a parallelogram from two congruent trapezoids. And again, the word decompose just means to break apart. And so you can break apart a parallelogram into two congruent trapezoids. You just turn it over, flip it over, put it together like a puzzle piece. And so the area of a trapezoid is going to be 1/2 the product of its height and the sum of its base, base 1 and base 2. Okay, so looking at this trapezoid, this is base 1, this is base 2. So what we'd have to do is add those two together. And as you can see, base 1 and base 2 are going to make the base of one parallelogram, but you'd have to put the two together. So you have to put the two together. So that's why we have this. It looks very much like a triangle area formula, but instead of base times height, you have to create the base by adding the little bitty trapezoid base with the larger trapezoid base to get the base. So there's an extra step in the process. Down here is just more of an explanation. The height is the perpendicular distance between the two bases. You've got the right angle showing perpendicular. The two bases are parallel. They will always be parallel and distant apart. And to create the parallelogram base, to do our formula, you add the two bases together. Okay. All right. So you have to add those two before multiplying. And so please review all that. So let's go ahead and see some examples. Before we actually look at using the formula, I want to focus on the shape of this trapezoid. This is an example of a trapezoid that's not a regular trapezoid. It's not, doesn't have like an isosceles kind of feel to it. So if we look up here, you'll notice this particular trapezoid, which is a regular trapezoid, this part and this part are congruent. But this distance and this distance are not congruent. So they are both types of trapezoids. We're used to seeing this shape as the classic trapezoid shape, but really all you need in order for something to be a trapezoid is to have one pair of parallel lines. And as you can see, this very short base, if we extended this line going on forever and ever and ever and ever and ever, those will never cross each other. These are parallel, but these two are going to eventually cross each other. So those are not parallel. Okay. So, but this is definitely a trapezoid. So let's go ahead and look to see what they did to fit this into the formula. So area is equal to 1/2 height times base 1 plus base 2. And this is going to be in parentheses. So order of operations means you must add these two together first. So we have 5 plus 12 is 17. Okay, so then we have the height, which is 7 and 1/2. So now we have 1/2 times 7 and 1/2 times 17. Okay, in this point, because all of these things are now, it's all now multiplication, these can be done in any order whatsoever. Let's go ahead and we'll do the 1/2 part at the very end. So they magically have come up with the answer, but let's go ahead and do this on our own. So the first thing we have to do to multiply 7 and 1/2 by 17 is we have to create this as an improper fraction. So we're going to have 1/2 times. This will still have the base of 1/2, so we're going to have the 2 as the denominator up here. So I don't know why I said base. Well, I mean, I know why I said base, but that's really, the denominator will still be 2. So 2 times 7 plus 1. What is this numerator going to be? Go ahead and answer that for me, please. Very good. 2 times 7 is 14 plus 1. That's going to be 15. So 7 and 1/2 is the same as 15 halves. And then we're going to multiply that by 17, which is the same as, okay, I don't know why I wrote 12. That's crazy. Same as 17. I'm fixing that mistake. Over 1. Okay. Now I'm looking, and I don't think I can really simplify anything this before we continue. So let's go ahead and we're going to multiply all the way across the denominator. 2 times 2 times 1. So the denominator is now going to be 4. And 1 times 15 times 12. All right, so everyone needs to go ahead and multiply 17 times 15 for me. Go ahead and do that. All right, so we end up getting 255 divided by 4. So now we have to define the area. Go ahead and simplify that by doing the division. So let's go ahead and solve for me. What is 255 divided by 4? All right, then you're going to go ahead and 4 will go into 25 6 times. Subtract the 24, you get 1. Bring down the 5. 3 times 4 is 12. Subtract that, you get 3. And then you end up with 3 as a remainder, so you're going to put the divisor and as the denominator underneath that. 63 and 3/4 square inches will be the answer. All right, so we're looking at another example they've done for us, and that is 1/2 times the height. The height is going to be 9 and 8/10, and you can see that instead of dropping that inside, they've actually done their perpendicular line on the outside. That's perfectly fine. So then we have the base. Small base is 7, large base is 12. So 7 plus 12 is 19. We multiply that by the height, 9 and 8/10, and then we divide it by 2, or multiply by 1/2. Now, since this particular situation is decimals, basically, to me, it's easier to think about it like once we get this product together, which is going to be 19 times 9 and 8/10, and we're not going to panic. 8 times 9 is 72, and then that's going to be 15. Put the 0 down, and 9 times 9 is 81. 9 times 1 is 9, plus 8 is 17. So once we add these together, I'll make sure that's clear so I don't make a mistake. 2, 6, 8. Then we're going to bring the decimal point over 1 time. So we're going to take 186 and 2/10, and we're going to divide that by 1/2, because in the formula, 186 and 2/10 divided by 2. Okay, now this says multiply by 1/2, but dividing by a whole number 2 is equivalent to multiplying by 1/2. And if you want to multiply by 1/2, we could do that. We're gonna if you want to use decimals, you could actually take the 186 and 2/10. You could actually multiply that by 1/2, which was 5/10 as well, and you're going to end up getting the same answer. So 9 times 2 is 18, and that's 0, so bring down the 6. 3 times 2 is 6, that's 0, bring down the 2. 1 times 2 is 2, so 93 and 1/10. Or over here, if we multiply by 1/2, which is equivalent to 5/10, then 5 times 2 is 10, carry the 1. 5 times 6 is 30, plus 1 is 31, carry the 3. 5 times 8 is 40, plus 3, 43, put the 3 down, carry the 4. 5 times 1 is 5 plus 4 is 9, and we get 9,310, but then we move the decimals twice over to the left, and we get 93 and 10 hundredths, with the same as 93 and 1/10. So either way is fine. In the final example we're going to talk about, it says determine the missing height, or determine the missing amount. And they've decided that they're going to do this weird thing where they reconfigure the formula as height is equal to 2 times the area divided by b1 plus b2. You actually don't have to do that at all. That's crazy talk. So I'm going to do this using the regular formula. So you have my permission to, you can look at what they've done, that's great, but we're going to expand the field here. We're going to do this the other way. All right, so we're going to use the regular formula, and then we're going to calculate what the missing height is using algebra. So 108 is what the area is according to the problem. That is equal to 1/2 height times base 1 and base 2, which is 12 and 15. So we're going to go ahead and add those two numbers together because parentheses go first in order of operations. Okay, if you answered 27, you were correct. So 108 equals 1/2 times h times 27. Okay, so now we're going to start getting rid of the things on the right side of the equation, so we can just leave the height by itself. So to get rid of multiplying by 27, what operation are we going to do? Okay, very good. We're going to divide by 27. My pen's acting weird, so we're just going to we're going to power through this. That is a 27, supposedly. Kind of? Okay, that's a little frustrating. All right, so that means this side also has to be divided by 27. Okay, well, that's fun. All right, I'm going to pause so I can rewrite this a little bit better. Okay, so I just left this as an improper fraction. So 108 divided by 27. And then this 27 over 27 became 1, so we have 1/2 times h. So now we have to get rid of this 1/2 in order for the h to be by itself. So what would be the opposite of 1/2? How do we get rid of this? Well, it's going to actually be multiplying by 2 over 1. So the inverse of 1 over 2. So if you multiply by 1/2, the opposite operation for you to do would be to multiply by 1 or by 2 whole. So this and this cancels out, and we're going to be left with just the h. And so we have to do the same thing to this side. We have to multiply this side by 2 over 1. So now we're left with just doing what's left over here. So 2 times 108, 1 times 27. So I need you to go ahead and calculate for me, because 1 times 27 is just going to be 27. Okay, pen's driving me crazy. All right, so go ahead and divide or multiply 2 times 108. Okay, if you said 216, you're correct. And you could probably just do this in your head. A plus 8 is 16. 100 plus 100 is 200. So 216 divided by 27 is going to be equivalent to the height. So that's the last thing that we need to do. So over here to the side where I have some space, and I know some of you will prefer to do this on notebook paper. That's fine. There is space in the book to do the math that you need to. Either way, I need to see the actual math. So if you're doing this on notebook paper, please take a picture of that so I can see it, because I will not give you credit if I don't see your actual work. So go ahead and divide 216 by 27 and leave that as a mixed number if needed. Okay, so we end up getting 8 as our answer. And as you can see, with their crazy formula, they agree with us. If we use the standard regular formula and use algebra, we got the same answer. So the height of that particular trapezoid is going to be 8 feet. All right, at this time, I want you to think about what the most important things are that we need to remember about this lesson. Answer that for me thoughtfully. Please do not give a silly answer and lose all your points for watching this video. Go back and review your notes. Look at what's written in the book. Tell me something important. Go ahead and do that for me now. Very good. Thank you for your thoughtful answer. And please come to class. Please ask questions. Don't forget we have math help as well. I know all of us can do this. We just have to kind of follow the formulas. And if you're struggling with multiplying by fractions or decimals, or dividing by fractions or decimals, or just generally fractions and decimals, come to math help so I can help you out. Thank you.